Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. It's Black Friday. Traffic spikes 20 times in 20 minutes. The data pipeline buffer overflows. Transactions start failing. $2 million in revenue evaporates before anyone can restart the server. That's the kind of problem skilled data engineers are paid to prevent. Companies generate enormous amounts of data, but that data is only valuable if they can ingest it, process it, secure it, and turn it into reliable business insights. Google Cloud professional data engineers specialize in building those systems on GCP. And when you combine these cloud skills with SQL, Python, data modeling, and real hands-on projects, you're building a skill set that can compete for some of the most valuable roles in cloud and data engineering. The Cert proves you can design, build, operationalize, secure, and monitor data processing systems on GCP. BigQuery, Dataflow, Sub, cloud storage, you aren't just naming them, you're architecting with them. It's a professional-level badge, not an entry-level one. Google expects you to have meaningful hands-on experience. This is what a certified GCP data engineer actually works with. BigQuery for serverless data warehousing. Dataflow for stream and batch processing. Sub for messaging. Cloud storage for object storage. Cloud Composer for orchestration, and Vertex AI to operationalize machine learning. Employers expect you to know all of them, not just one. 5 years ago, you'd drop 6 figures on a Hadoop cluster, then spend weeks tuning it. Today, with BigQuery and Dataflow, you pay per query. Everything auto-scales, and encryption is built in. That shift isn't just cheaper. It makes entire business models possible. Companies that understand this are hiring certified data engineers to lead the migration. So what does this certification actually tell an employer? It signals that you've studied how to design data systems on Google Cloud, not just how to use one product. You're expected to understand scalability, reliability, security, performance, and cost, and make trade-offs between them. It won't replace experience or a technical interview. But on a resume filled with similar candidates, it can give recruiters another reason to take a closer look. Now let's talk about that 6-figure salary claim. Companies aren't paying data engineers because they collected a certification. They're paying for a valuable combination of skills: SQL, Python, data modeling, cloud architecture, distributed processing, security, and the ability to turn massive amounts of raw data into something the business can actually use. Google Cloud expertise adds another specialization on top of those fundamentals. That's the opportunity behind this certification. Not a guaranteed salary, but a path toward developing skills used in high-value cloud data roles. Look at the exam fee as a training investment, not a lottery ticket. For a few $100s, you're giving yourself a target that forces you to learn an entire professional data platform. From ingestion and storage to transformation, security, monitoring, and machine learning integration. Even if the certification itself never directly gets you a job, those skills remain valuable. That's a much better way to calculate the return on investment. According to Google's Certification Impact Report, the vast majority of certified pros feel more confident in their cloud skills, and nearly 4 out of 5 reported greater confidence in their professional future. That's the kind of momentum that turns a job into a career. There are no formal prerequisites to schedule the exam, but don't confuse that with beginner-level difficulty. This is a professional-level certification built around architectural decision-making. You may be given several technically valid solutions and asked to choose the one that best meets requirements for scalability, reliability, security, performance, or cost. If your preparation has been mostly theoretical, those questions can be difficult. Hands-on experience changes everything because you've already seen these trade-offs in practice. Here's one of the biggest mistakes you can make: studying Google Cloud like it's a vocabulary test. Memorizing that pubjar sub is messaging and BigQuery is a data warehouse isn't enough. The exam might give you a company processing millions of events, strict latency requirements, limited operational overhead, and a requirement to minimize cost. Then it gives you several answers that could technically work. Your job is to identify the best architecture. So when you're studying, stop asking only, what does this service do? Start asking, when would I choose it, and why would I reject the alternatives? That's the mindset this exam rewards. You can simplify the exam into 5 actions: design, build, operationalize machine learning, ensure quality, and secure. First, you design data processing systems and decide things like batch versus streaming, and which storage technology fits the workload. Then you build and operationalize those systems. You also need to understand how data engineering supports machine learning workloads. Next comes solution quality, monitoring, reliability, performance, and troubleshooting. Finally, you need to secure the entire environment. Remember those 5 ideas because almost everything you study connects back to them. Let's apply that thinking to a real architecture. Imagine thousands of point-of-sale terminals sending transactions every second. First, those events enter pub, batch, or sub, giving us a scalable messaging layer between the applications producing the data and the systems consuming it. Next, Dataflow processes the stream in real time. It can transform the transaction, enrich it with additional information, and prepare it for analysis. Then, the processed records land in BigQuery, where analysts and applications can query the results almost immediately. So remember the pattern. Pub, cha, sub ingests, Dataflow processes, BigQuery analyzes. The exam can replace retail transactions with IoT sensors, application logs, or clickstream data. But the architectural reasoning remains similar. Storage questions become much easier when you stop asking, where can I store this? And start asking, what does this workload need? Need large-scale analytics and SQL? Think BigQuery. Need a traditional relational database for an application? Consider Cloud SQL. Need globally distributed relational transactions at scale? That's where Spanner enters the conversation. Need raw files, images, backups, logs, or a data lake? Cloud storage. Need massive low-latency key value or time series access? Think Bigtable. Need document-oriented data for an application? Firestore may be the better fit. Several Google Cloud services can store data. The exam wants to know whether you understand why one is the best fit for the workload. Now, you're not expected to be a machine learning researcher. But as a data engineer, you'll be the one feeding the ML pipeline, and the exam expects you to know when to operationalize a model with Vertex AI, when to run a quick regression right inside BigQuery ML, and when a business stakeholder just needs AutoML to kick out a prototype without writing a line of code. It's about the right tool for the job, not building the fanciest model. And once your pipeline is running, the exam expects you to keep it running. The ensuring solution quality domain covers observability. Imagine a streaming job that starts lagging. Dataflow pushes metrics to cloud logging. You build a dashboard in cloud monitoring that shows throughput and latency, and you set alerts to ping you before a backlog burns through your budget. That loop is not just a nice-to-have, it's on the test blueprint. Security isn't something you bolt on after the pipeline works. It's part of the architecture. Start with encryption at rest and in transit, and understand when customer-managed encryption keys are required. Use IAM roles and service accounts to enforce least privilege between users, applications, and services. VPC service controls can create security perimeters around supported Google Cloud services to help reduce the risk of data exfiltration. And sensitive data protection capabilities can help discover, classify, mask, or de-identify information before it spreads through your analytics environment. On the exam, security requirements can completely change which architecture is considered the best answer. Here's where architecture directly affects your cloud bill. Imagine a massive BigQuery sales table containing years of transactions. If every query scans the entire table, you're processing far more data than necessary. Partition the table by date and a query asking for last week's sales can scan only the relevant partitions. Then cluster the data around frequently filtered columns, such as store ID, to reduce the amount of data BigQuery needs to examine even further. And when an exact answer isn't required, functions such as aprox count distinct can reduce the computational work involved in large aggregations. The lesson isn't to memorize 3 optimization tricks. It's to understand that in cloud data engineering, performance and cost are often connected. If your training plan gives you access to Google Cloud credits, don't treat them like free money. Treat them like a lab budget. Give yourself specific missions. Build a PubChar subtopic and publish events to it. Create a Dataflow pipeline. Load data into BigQuery and compare an inefficient query with a partitioned one. Configure IAM incorrectly in a safe lab, observe what breaks, then fix it. Set up monitoring and deliberately create a condition that triggers an alert. That's how cloud credits become experience instead of disappearing into resources you forgot to shut down. The certification is valid for exactly 2 years. Some people see that and think, ugh, recertification. But employers see it the opposite way. GCP evolves fast. BigQuery, Dataflow, Vertex, AI all drop new features every quarter. A 2-year validity period signals that you're demonstrably up to date, not just someone who passed a test once and coasted. It's a career velocity signal, not a burden. And by the time you need to recertify, you'll have 2 years of real-world projects to back you up. This certification doesn't lock you into one job title. The most obvious path is data engineer, where you're building pipelines, designing storage, and optimizing data processing. But these skills also support cloud architects who need to design enterprise data platforms and ML engineers who depend on reliable pipelines to move data into production machine learning systems. They can even benefit technical analytics leaders responsible for large-scale data platforms. Think of the certification as evidence of a broader Google Cloud data skill set, not a ticket to one specific job. When people hear data engineering, they picture a Silicon Valley startup. But the biggest rush for Google Cloud data pros isn't just tech. Finance, retail, healthcare, media, they're all migrating massive workloads to BigQuery and hiring certified engineers to run them. If you think this cert only matters to one sector, you're missing the entire market. So after all of that, is the professional data engineer certification worth pursuing? If you already work with data or cloud technologies and want to specialize in Google Cloud, it can give your learning a strong structure and validate that specialization. If you're completely new to IT, however, I wouldn't make this your first certification. Build foundations in SQL, Python, databases, cloud computing, and basic data engineering first. And if your only goal is adding another badge to LinkedIn, there are easier ways to spend your time. This certification makes the most sense when the knowledge behind it aligns with the career you're actually trying to build. If you're serious about this exam, treat it like a real technical training program, not a weekend cram session. Here's a practical 90-day roadmap. Month 1. Build your foundation in BigQuery, SQL, storage design, partitioning, clustering, IAM, and the core GCP data services. Month 2. Move heavily into hands-on labs. Build pub sub-pipelines, process streaming, and batch data with Dataflow. Orchestrate workflows and monitor what you deploy. Month 3. Shift toward architecture scenarios. Practice questions, troubleshooting, security, and weak areas. The goal isn't to memorize enough answers to pass. The goal is to reach the point where you can explain why one architecture is better than another. The difference between passing and failing often comes down to how you study. On the work side, the official Skills Boost courses, Quick Labs quests where you actually type commands, and the Google-provided sample questions. On the fail side, brain dumps, passive video marathons, and skipping the architecture case studies. This exam tests design decisions, not trivia. If you've never opened a cloud console, you're not ready yet. Let's connect the architecture to code. A basic Apache Beam streaming pipeline follows the same flow we've already discussed. First, configure the pipeline to run in streaming mode. Then read incoming messages from pub sub. Next, transform or window those events depending on what your application needs. Finally, write the processed output into BigQuery. That's the important part to understand. The Python syntax can change. Your transformation can become far more complicated. But the underlying flow remains: ingest, process, transform, and write. If you understand what every stage is doing and why it exists, you're thinking beyond memorization and starting to think like a data engineer. Here's a concrete test-taking strategy. Allocate about 2 minutes per question. If a scenario question takes longer, flag it and move on. Come back after you've answered everything else. Read the last sentence of the prompt first to identify exactly what's being asked before wading into the details. And take the official practice questions at cloud.google.com certification guides. They mirror the real exam's decision-driven style. This timing discipline turns a 2-hour gauntlet into a manageable set of decisions. If you want to turn what you're learning into something you can show an employer, build 3 projects. Project 1. A real-time pipeline. Send events through PubSub, process them with Dataflow, and analyze the results in BigQuery. Project 2. A batch analytics pipeline. Start with files in cloud storage, transform the data, load it into BigQuery, and orchestrate the workflow. Project 3. Take one of those systems and make it production-minded. Add IAM, monitoring, alerting, error handling, and cost controls. For each project, include your code, an architecture diagram, and a README explaining the problem, your design decisions, and what you would change for a real production environment. Now, your portfolio isn't 3 tutorials. It's evidence that you can design systems. And if you're thinking, I don't have a computer science degree, don't let that stop you. There are no formal degree prerequisites for the certification, but there is an important difference between no degree requirement and no skill requirement. You still need to develop real technical ability, especially SQL, Python, data modeling, ETL and ELT concepts, cloud architecture, and hands-on experience with services like BigQuery, PubSub, and Dataflow. Your background matters less when you can demonstrate that you understand the technology and can build something with it. Let's see if you're starting to think like a Google Cloud data engineer. Your company receives millions of events from applications every second. Those same events need to feed multiple independent systems. One pipeline updates a real-time analytics dashboard, another performs fraud detection, and another archives events for later processing. You need a scalable messaging layer that can decouple the producers from multiple consumers. Which Google Cloud service would you choose? 3, 2, 1. PubSub. And here's the important part. You shouldn't choose it simply because you memorized PubSub equals messaging. You choose it because the architecture requires asynchronous event distribution, scalability, and multiple independent subscribers. That's the reasoning the exam is looking for. If this certification is now on your radar, here's what I would do during the first 7 days. First, open the current Professional Data Engineer exam guide and study the domains before buying any course. Second, create a Google Cloud practice environment and set a strict budget, so experimentation doesn't turn into an unexpected bill. Third, build one simple pipeline, PubSub to Dataflow to BigQuery. Don't worry about making it impressive. Your objective is to understand how data moves through the architecture. Then deliberately change something. Add a transformation. Create an error. Inspect the logs. Fix it. By the end of the week, you should understand one working pipeline from beginning to end. That's a much stronger starting point than memorizing 50 service definitions. And if you're trying to figure out where this certification fits into a larger IT career, I've created a free IT career roadmap. It covers the bigger journey, what to learn, which skills to build, how to create portfolio projects, how to strengthen your resume, and how to prepare for technical interviews. You'll find the link in the description. Use the certification as one milestone. Use the roadmap to understand where you're going next. So, is a few $100 certification going to magically hand you a $150,000 job? No. But can the skills behind the Google Cloud Professional Data Engineer certification help prepare you for serious cloud and data engineering opportunities? Absolutely. Learn the architecture, build the pipelines, understand the trade-offs, then prove what you can do. Thanks for watching Hired in IT, where we're turning IT knowledge into career opportunities.